This is our last video about finding missing parts of triangles. Today we're exploring the law of cosines. You can see it on your screen right now. The law of cosines is kind of messy, so we pretty much only use this one as a last resort. If you're solving a triangle, you always first want to go through your right triangle tricks. So can I use Pythagorean theorem, 45, 45, 90, 30, 60, 90? If none of those work, then you go into your right triangle trig. If that won't work, you try out law of sines. And if that doesn't work, as a last resort, we try out law of cosines. So in a triangle with sides lowercase a, b, c, and angles uppercase a, b, c, then a squared will equal b squared plus c squared minus 2bc times the cosine of angle A. And you can rearrange those to be whatever angle you're talking about. They're all the same thing. They're just rearranged for different angles. So if I want to find B in this triangle, I want to use a form of law of cosines that tells me just about B. So we'll use the fact that B squared should equal A squared plus C squared minus 2AC times the cosine of B. Let's go ahead and write that down. And this is something that I wouldn't expect you to memorize because I tend to look it up every year before I teach it to make sure that I actually remember it correctly. All right, let's take this formula and plug in what we know. So B is what we're trying to find. So that's going to stay a variable. A, the side across from angle A, is 78. C is 80. And angle B is 40. All right, and then we're going to simplify this the best that we can. So 78 squared is 6,084. 80 squared is 6,040. Or 6,400, sorry. 2 times 78 times 80 would be 12,480. And then right away, while I have it in my calculator, I'm just going to multiply that by the cosine of 40. I got 9,560.23. That's all equal to b squared. Let's combine some things over on the right. And then to get b by itself, I'll take the square root of each side. So b is about 54.07, and we don't have a unit. So again, law of cosines, it's very doable. It's just typically some big numbers and some crazy algebra. So we try and avoid this, but if it's a last resort, you can use it to solve for missing sides. And you can also use it to solve for missing angles. So in this one, we're given that A equals 11, B equals 4, C equals 19, and we want to find the measure of angle A. If you want to draw out your triangle, go for it. We don't necessarily have to. A, B, C. So A would be across from angle A, B would be across from angle B, C would be across from angle C, and we want to find that angle. So I need to use the form of law of cosines that tells me about A. Well, we don't have one that tells me directly about angle A, but we do have one that has an angle A in it. So then I'll be able to solve for angle A. So our big equation is going to be A squared equals B squared plus C squared minus 2BC times the cosine of A. And then we're going to plug in what we know and solve for angle A. So, and maybe I'll do some space below because this is going to get really long. A squared equals B squared plus C squared minus 2BC times the cosine of angle A. So side A, it looks like, is 11. Side B is 14. Side C is 19. So we want to solve this for A. Let's do a little simplifying first. 11 squared I know is 121. 14 squared is 196. 19 squared is 361. 2 times 14 times 19 is 532. So our goal is to get A all by itself. Let's start by subtracting what we can. So 121 minus 196 minus 361 will be negative 436. That's equal to negative 532 times the cosine of A. Again, we're trying to get A all alone, so let's divide each side by negative 532. If you want to, you could simplify that fraction. I think all I'm going to do for now is get rid of the negative signs because I know that they're going to cancel off. So we'll say we're left with 436 over 532. Again, you can simplify it, but I'm not going to because I'm just going to put that in a calculator anyways. And then to get A by itself, I have to take the cosine inverse of each side. That's going to cancel, so I know A would be the cosine inverse of 436 over 532. So to get cosine inverse, I'm going to press the second key on my calculator and then cosine. 436 divided by 532. Angle A is going to be 34.96 degrees. All right, that's the law of cosines, our last trick for solving for missing sides or angles in a triangle. And if the law of cosines doesn't apply, the law of cosines will only apply if you have the scenarios we had here. So in the first one, we had two side lengths. and the angle between them. And in the second one, we had 3 side lengths. If you do not have either of those situations, then the law of cosines doesn't apply, and we are not able to solve the triangle.